Hi, my name's Nick Wagner. I'm a program manager in the input and composition team. I've been working at Microsoft now going on 8 years. When I first started, I was a developer in the Windows deployment team. After that, I moved over to the security division where I was a program manager working on internet scale web services. But for the last 3.5 years, I've been having a lot of fun back in touch working on the Windows team. I've worked on everything from the depths of the input stack up to touch optimized controls, but I have the most fun helping developers like you build great touch apps. So today I'm going to talk to you a little bit about how you can take advantage of the power and flexibility of the input stack. But before we get into that, I want to show you a demo that has a lot of these concepts already built into it. Let's jump over here now to Visual Studio. And here we've got a project that's already built. And so what you're seeing here is a XAML app that's using a swap chain background panel and D3D in order to render the teapot. So what we're going to do today is we're going to actually wire up taps so that you can make the model change colors. We'll allow you to slide the finger on the screen so you can rotate the teapot, complete with that nice inertia effect. You will let our customers bounce and zoom using their fingers. And then finally, we'll allow them to go ahead and reset the view by pressing and holding, as well as manipulating the model itself. Great. So the model that you just saw is actually powered by a couple of gesture recognizers. The first one is for the teapot, and then there's also another one for the world or the view. Now those gesture recognizers analyze input to provide the relevant data about the gestures to you. They make it quick and easy for you to incorporate the Windows touch language into your app. Now we're going to spend a little bit of time today talking about what the touch language is, the programming model for those recognizers, and how you can use them to build your experience. After that, we're going to take a deeper look at the manipulations. These are the things like pan, zoom, and rotate, where your customers feel like they're directly interacting with the content. We're going to take a look at the two phases of those manipulations. And we're going to show you a technique for things that you can use, like changing the physics in a mini golf game so that a golf ball rolls differently through the fairway versus through a sand trap. Or maybe you want to show your customers how much force they're putting on a slingshot by having it change and slip behind the finger as they're pulling it back. After that, we're going to go beyond a single recognizer. And so if you're building something as simple as a jigsaw puzzle, or if you're doing something as sophisticated as a 3D world, we'll show you how to use multiple gesture recognizers together in concert. And then finally, we'll take a look at XAML and DirectX and some of the features there so that you can harness the power of the platform in order to get more control over how input is handled in your app. When we first set out to reimagine Windows 8 to be a touch-first OS, we spent countless hours observing, testing, and measuring how customers interacted with the system. What we arrived at was a set of 7 simple gestures, the Windows touch language. That touch language has been embedded in everything from our controls to the templates to the apps that we build. If you want to learn more about how you can design for the touch language, you can look at a link at the end of this deck. Now, there's one point that I want to make right now, which is those gestures that are in the touch language, they're used everywhere. So whether it's the start screen or other apps, this is the way that your customers have learned to interact with the system. So if you use the touch language in your app, it'll be very easy for your customers to immediately and intuitively know how to use your app. Now, first impressions are key. Often customers make up their mind about whether your app is good or great based off of the first few touches they make on that app. Now, in order to help you nail that first impression, there's a few things you should do. First, you should design your experience with the app templates and controls in mind. If you look at the details of a touch interaction, what you'll find is that there's a lot of little nuances to it. The app templates and controls have already taken care of all of those nuances for you to make your app feel great. So if you just use those out of the box, you're already set. Now, if they don't quite provide what you need, the next thing you should think about is how you can use the Windows touch language in your app. Those 7 simple gestures are going to be the first thing that your customers think of when they try to use your app. Now, those gestures have been plumbed through each of the different UI frameworks, and it makes it easy for you to get access to them. But you can also get access to them from the gesture recognizer, and that's what we're going to talk about today. And finally, if it's going to be clear to your customers that the world is different, or that it should be different. So for example, maybe inertia should feel different because it's actually a hockey puck sliding on ice. Taking advantage of the power and flexibility of the input stack can really make your app shine. So a gesture recognizer is a math engine that analyzes input in order to detect those gestures. Now, in order for it to do that analysis, you have to feed it pointer information, so raw input. The way you get access to that input is via pointer point. Now, Pointer Point was introduced in Windows 8 as a way to unify the different pointer devices. What this means for you is you can code for Pointer, and you'll get an experience where touch, mouse, and pen all just work. Now, Pointer has all of the data that is common across devices, but if you want to go beyond that, you can access input-specific properties in order to make your app shine for that type of input. So now that you've got the input, you need to feed it to a gesture recognizer. Now, the gesture recognizer can detect two classes of input. The first kind are the one-time gestures, the things like tap and hold. And what happens here is you'll actually get an event that signifies that your user or customer has done something. So for example, if you take press and hold, when the user's finger comes down on the screen and it's been held there long enough, you'll get one event that signifies that they've started a hold. And then you'll get another one when they release their finger. In contrast, there are things like the manipulations. These are the things like translate, rotate, and scale, where you're going to get a stream of information about what the user is doing while they are doing it. So again, taking an example, as the user slides their finger across the screen, you're going to get information each step along the way about how far that finger is translated. So now that we've gone ahead and we've covered some of the bases, let's go ahead and jump over to Visual Studio and actually code this up. And so we're going to take tap, press and hold, and pinch directly from the touch language and plug it into our model. And we're also going to take the translate and use it to rotate the model. All right, so now we're in Visual Studio. And so what we have here is we have a project where we've already got the teapot being rendered by DX. And so what we're going to do is we're going to create a class that handles all of the input and all of those gestures for us. So let's start just by defining it. And now what you see here is very boilerplate code. About the only thing that we've done is we've created a constructor where we can pass in the teapot renderer, and so that we can go ahead and push updates to the model. So now let's go ahead and declare our event handlers. So these are the Pointer event handlers. These are the things that we're going to use to get the input to feed our recognizers. And the other thing we've declared here is we've declared this update function. And so this is going to get called in the render loop in order to allow us to push updates to the model before it gets drawn. So next, let's go ahead and declare our gesture handlers. And so these are, again, very straightforward. We just got a few of them here, the hold, the tap. And then for the manipulations, for that pinch and translate, we're just going to use the updated and complete. There's also a started one, but we don't have anything that we're going to use it for today. And the last thing that we've done here is we've gone ahead and declared a few member variables so that we can store off some state. So now let's jump over to the implementation here. All right, and so the first thing we're going to do is we're going to jump into the constructor here. And so what you're seeing here is the constructor is pretty straightforward. It's basically just taking that teapot render and storing it off so that we have access to it later. It's going to go ahead and instantiate a gesture recognizer and then configure it for our 4 gestures. You'll notice that we've also configured inertia for the translate X, and this is how when you do that rotate, it keeps spinning around. And then finally in this constructor, what we're going to do is we're going ahead and actually wiring up all of the different gesture recognizers, or all the different event handlers. And then finally, our update function here, it's very straightforward. All we're doing is just pushing our internal state over to the model. So next, let's take a look at the Pointer event handlers. Now the Pointer event handlers are very straightforward. All they're really doing is getting the point and passing along to the recognizer. Now the only thing to note here is the get intermediate points. And now what this is doing is it's getting all of the points since the last time you got a pointer moved event. And the reason why that's important is if you're trying to do gesture detection, you want to get all of the data, not just the last point. And so now that that's done, let's go ahead and talk through the gesture handlers themselves. And so on the view holding, we're going to just check to make sure that we're doing it at the start. We're not going to do it on finger up, but we're going to do it at the finger start. And all we're going to do is just run through very quickly, and we're just going to reset a bunch of the states. We'll reset the material color, the rotation, and the scale. When we actually tap on the view, we're just going to make a call to our renderer again, and we're just going to change the material color. And then finally, the view manipulation updated. So this is our handler that happens as the customer's sliding their finger or pinching in. And all we're going to do is we're going to update our internal state about the scale and the rotation. All right, so now we have to wire this into our actual control here. And so let's go ahead and include the controller. So we've included the controller, and let's declare a variable to store it off in. Great. And now we'll jump over to the constructor here for the teapot. panel, and where we've initialized the renderer, we're going to go ahead and drop in our controller and register the event handlers. And so it's very straightforward. We just pass it in, and we've gone ahead and wired up the event handlers. And the last thing we need to do is we need to actually call update from the render loop so that the model actually draws differently. Great. So now we've got that. Let's go ahead and show that running. And we're compiling away here. And here we go. It's almost through. Great. And so now you'll notice the tap actually changes the model as you would expect. We can go ahead and rotate through. And then pinch actually triggers. But look, it's not exactly what you would expect, is it? There's no boundary, and it just keeps moving. We'll show you how to fix that in the next section. So now let's jump back here. We're going to head back over to the slides. Great. So before we jump into the bounce effect, I want to take a little bit of time to talk about what goes into gesture recognition. So when we first started looking at gesture recognition, we knew there were a few things we needed to account for. First, customers are different. We took a look at all the data we had, and we observed that customers' touch interactions are sloppy. Whether it's fat fingers, the intuitive gestures, or the direct nature of touch, customers just don't interact precisely with it. On top of that, every customer interacts just a little bit differently than the next. Devices are also different. Now, in order to get a logo, a device has to report input at least 100 Hertz, but it's free to go beyond that and report at any frequency that makes the most sense for it. On top of that, depending on what else is running in the system or what your app is doing, the spacing between those inputs can vary. Now, if you take a look at the gestures themselves, the defining parts of most gestures are what happens in the real world. So for example, take tap and drag. When a customer tries to tap, their finger doesn't actually come straight up and down. Instead, it slides a little on the screen. Now, you could try to differentiate between a tap and a drag based off of the number of pixels or the amount of content that the finger slid across. But what actually differentiates a tap and a drag is what happens in the real world. It's how far that finger slides on the screen. And finally, another thing that we knew we had to look at was how the gestures actually interacted with each other. We knew that we could improve the algorithm and the experience if we accounted for what was actually enabled and present in the system. So again, look at tap and drag. In order to account for that little motion between the down and the up, there has to be a threshold to detect the tap. But that threshold introduces a small latency to starting the drag. But if a tap isn't possible, why not let the drag just start immediately? So what does all of this mean for you? Don't start from scratch. Use the gesture recognizer as the basis for building your specialized gestures. It's already been designed to feel great for your customers and across devices. So start with a gesture recognizer, wrap it, process its output, and use it to build your scenario. Now, one of the most interesting times to wrap a gesture recognizer is when you want to override part of a manipulation. So let's get back to our bounce effect. Now, as the user is pinching, we're getting a stream of updates describing what the current scale factor is. But we can actually do a little better, and we can break that stream down into two phases. The first phase is the manipulation phase. And this is where the customer's fingers are actually on the screen, moving the content around. The other phase is the inertia phase. And this is where the content is still moving on screen, but your customers are no longer touching it. Now, our bounce effect is going to need to account for both of these phases. Before we continue on, though, let's take a look at the system panning in order to see how it's done. All right, so here we are in the start screen. And what I want to show you here is how the system does panning. And so what you'll notice is, as I move my finger on the screen, the content just follows along. And when I lift up, it just moves. And so what's going on under the covers here is there's actually a gesture recognizer that the system's using. And it's when you're in between the boundaries and in the middle of the content, it's just taking the output of that recognizer and applying it directly to the surface. And now what you'll notice is if I pan past the beginning of the content, my finger starts slipping over the top of the content. And then when I release, it bounces back. So it runs that nice little inertia animation in order to bring you back within bounds. And the last thing I want to show you is if you give a lot of inertia, you'll see how it continues on its own, and then it transitions into that bounce effect. So now let's jump back over to the slides. And I want to talk a little bit about what is the state machine for a bounce effect? And so what you're seeing here in gray is what is provided by default. And so when the finger's on the screen, the gesture recognizer is going to provide a manipulation phase, and when the finger comes off, you'll get a default inertia experience. Now, when the customer slides past the edge of our boundary, we're going to want to go ahead and do the same thing that the start screen was doing, and we're going to start applying our bounce effect. So we'll take the output from the recognizer and we'll modify it a little bit. Now, once we're into this state, there's one of two things can happen. The customer could bring their finger back in bounds, in which case we're just going to transition to applying the output of the recognizer directly, or they could lift their finger. And when they lift their finger, we're going to go ahead and trigger an animation to bring them back within bounds. Now, while this animation is running, they could put their finger back down again, and so we will have to account for going back into driving our manipulation phase. And then last, if you're building a full bounce effect and the customer gives a lot of inertia, you'll have to account for transitioning between the two inertia phases. Now we're going to jump back over to Visual Studio and we're going to code up these two blue boxes. There's one thing to note here though, which is we haven't enabled zoom or inertia for our zoom in our demo, so we don't have to worry about going between the two inertia phases. All right, so let's jump over to Visual Studio as promised. All right, and so we're going to jump back over to the controller here, and we're going to add a few more methods here, a couple of private ones. I guess one private method. So it's get bounded scale, and so what this is, it's going to take, it actually applies the mapping between the raw input that the gesture recognizer is passing us versus the output that we want to actually apply. And then finally, we're going to add a couple more variables for state again. So now we're going to jump over to our implementation, and we're going to define a couple of constants here. And so what these constants are is they're Bezier control points that we're going to use in order to drive that mapping. There's also a couple of other properties here. These are things like how long the animation should run for, what the actual boundaries are, and what the distance the bound should actually travel. So now let's go down and let's actually initialize our new member variables. Great. And now let's go take a look at our pointer pressed handler. So inside of our pointer press, now that we're thinking about inertia, when that finger comes down on the screen, we're going to want to stop inertia from running. And so we're simply going to update that flag and set it to false. And now let's go take a look at our gesture handler for update. And so before, we were just applying the scale uniformly. Now we're actually going to check to see if we're still within bounds, and if not, adjust it. So let's go ahead and add that code. And what you'll see here is just what I said. We're going to take the scale, we're going to check to see that we're still within the raw boundary. And so that's that we've gone far enough that we've hit the boundary, and we still are allowing a little bit of motion. And then after that, the other thing we're doing is we're checking to see if the recognizer says that it's an inertia. If it thinks it's an inertia, we need to check to see if we're out of bounds and need to drive it back in bounds. The other thing we need to do is we need to update our manipulation completed handler. And the only thing we're going to do here is we're going to check to see if inertia needs to be run now. And so the idea here is the user goes past the boundary and then lifts their finger without any real inertia being run. When that happens, we're going to want to trigger our animation to bring it back in bounds. All right, and then now we're going to implement that bounded scale. And so what we're doing here is we're checking to see if we're actually beyond the boundary. And if we are, we're just going to evaluate a Bezier curve and apply that. And so what you see here is that we've actually just normalized our input to this helper function to be a 0 to 1 based number. We pass in our control points, and then we're actually multiplying it by the distance that we want the bounce effect to actually take. Let me jump back here. All right, and we have one last thing to do. So far we've talked about setting inertia and watching for it, but we haven't actually implemented inertia. So we're going to go to our update handler, and we're going to actually update it so it drives inertia. And so let's go ahead and add the code for that. And so let me walk you through it now. So what you're seeing here is now we're checking that flag to see if we're in inertia. And then the very next thing we do is we check to see if we're over the boundaries. If we are, we go ahead and store off the start time so that we know how far we would need to animate. Or how long it's been since we started to animate, I should say. Now, the other thing is we use that same Bezier function to go ahead and compute the delta, so how far to move it back. And then we go ahead and just update our internal state about the scale. If we aren't actually over the boundaries, we're just going to set the inertia flag to false so that we don't have to keep processing this loop. And then the same thing here, we're going to go ahead and mark our start time as 0 if we're not actually processing inertia. And finally, we're going to go ahead and make the call. So now one thing you'll notice here is I've actually got this call twice. And I did that so that I could show you the other change that we made. So previously, we were just passing our raw information about the scale to the teapot. Now what we're going to do is we're going to use that getBoundedScale function in order to actually apply the bounce effect. So let me run that. Let me show you how it looks. And again, we're off and compiling. And any moment now, we should be along. Here it comes. All right, and so now you'll notice as my fingers move on screen, it actually slows down and stops. And when I lift, it animates back. And it works the other way as well. And so now we fixed that problem that we had in the previous step. So far, everything we've talked about and everything we've been coding has to do with one recognizer. But you can start to build some great experiences once you start using multiple recognizers. And so one of the most common ways to do this is to have one recognizer for each object. And so we're going to do that in our teapot example. We're going to put a recognizer for the teapot itself as well as a recognizer for the world or the view. Now, once you start using multiple recognizers, you need to think about how do you want to group contacts into those gestures. So one of the most common ways to use multiple recognizer is to use a single recognizer for each object. And so if you think about our teapot example, we're going to do just that. We're going to put a single recognizer for the teapot and another recognizer for the view. Now, one of the reasons why we started to build these gesture recognizers this way is we wanted to make sure that you could build experiences where your customers could interact with multiple objects at the same time. Now, once you start to use multiple recognizers, you're going to need to think about how you want to group the contacts into form those gestures. Now, the simplest way to do this is just based off of what was hit tested. But if you think about our example of the teapot, we actually have the teapot hosted inside of the view. And so when you have a hierarchy of objects like this, it's a common place where people want to go beyond that simple hit testing. And so if you're going to do that and you're going to go beyond it, you might want to allow multiple gestures to run at the same time. If you do that, you're going to build an algorithm that picks between those two gestures. When you think about that algorithm, try to design such that you're thinking about what are the things that are most important for your customers. What are the things that your customers most likely going to do? And should any of the gestures be able to interrupt each other? And so we're going to do that with the teapot. We're going to allow customers to go ahead and manipulate the teapot itself, but if they add another finger such that it touches the view, we're going to stop the teapot from responding and go ahead and have the view start zooming. So another way that you can go beyond a single recognizer is you can use the raw pointer information in conjunction with a gesture recognizer. And what this lets you do is it allows you to get the flexibility and power of the raw input in conjunction with the highly refined gestures from the touch language. Now, we're going to do the same thing here, which is with our teapot, we're going to go ahead and take a look at the pointer position on screen. And so that way, we'll use that data to drive how the mesh moves. And as well, if a finger comes down off, we'll go ahead and pop out. In addition, we'll also listen to tap and press and hold from the touch language in order to be able to change the color still and do the press and hold. So now we're going to jump over here to Visual Studio again. All right, so let's go ahead and get ourselves set up here. All right, so let's jump over to our controller. And now what we're going to do is we're going to add a couple more methods here. And so we're adding handlers for gestures directly on the teapot, or at least directly for the teapot. We're going to implement this little helper method called checkIfLeft, and that's just going to help us keep track of contacts. And then we're going to store away some additional state. The thing to talk about here is this is only being written right now for 2 fingers, and it's a pretty naive implementation, but the concept is there to show you how to do this. The left position is just going to be the position of a contact on screen, and the cumulative is going to be how far that finger is moved during the course of the gesture. So now let's jump back over to our implementation, and we're going to define another constant here. And so what this constant is just a scale factor. And so we're going to move the vertices in that mesh, all based off of how far that finger is moved. But since that is a multiplicative operation, we want to scale that way down. Otherwise, you're going to end up with massive manipulations with very little finger movement. So let's go down and let's initialize our new member variables. Great. And now let's go ahead and implement our check if left function. And really all this is doing is checking to see if the right finger has even come down at all, then it must be left. Otherwise, it's just going to take the position of the values and try to figure out which finger is which. So now let's go down to pointer pressed. And so here we're going to add some code so that we can actually do the finger tracking. And so let me walk you through it. So the very first thing that we're doing is we've gone beyond just looking at the pointer press because we're going to have to do some hit testing ourselves. And so that's what these first couple of lines are, is we're just getting the hit test results. Next, we're going to take a look at that result, and we're also going to check to see if we're already manipulating the view. If we are in a view manipulation, we're going to clear out our teapot recognizer so it doesn't fire any additional events. And we're also going to make sure that we set the state so that if another finger is added, it manipulates the view and not the teapot. Now, if this is the first time through, we're going to go ahead and create a teapot recognizer so that we can actually listen to those events that we just talked about. You'll see it's created very much the same, except that this time we're only wiring up hold and tap. Now let's go take a look at, oh, there's a little bit more here. So I mentioned the state before, so the other thing that we need to do is as we're going through this, we need to go out and store off where the finger came down at as well as how far it's moved. And so what we're doing is we're just kind of cleaning up the state and storing that initial position. This first if statement is for when the first finger comes down. The second one is if a second finger comes down. Last, we're going to go ahead and ask the teapot to create a vertex copy, and this allows us to go ahead and manipulate the mesh while allowing us to commit for the next one. And finally, we call process down event so that we can go ahead and get our gesture recognizer looking for those gestures. Now let's take a look at pointer moved. All right. So what we're doing here now is we're also going to get the most recent point, and we're going to take a look at a couple of things. First, we're going to check to see if we're actually manipulating the teapot. Because this is just a raw pointer event, we have to do this coordination now because it's no longer handled by the recognizer for us. And so that's the other piece of this as well. If the hold gesture has already occurred, we need to make sure that we don't go ahead and run this code. All right, and so now that we're in here, all we're doing really is we're checking which contact that we're tracking, and then we want to go ahead and update how far it's moved. And then this next stuff here, this next block of code, this is what is going through, and it's basically taking the current position, which is in screen coordinates, and it's pushing it down so that the coordinates are in the element coordinate space. And then finally, we're also going to multiply it by that scale factor, as I mentioned. This if block just goes ahead and accounts for the cases on whether or not there are two fingers down or just one. If there's only one finger down, we're going to use the same point because the effect that we're building is that from the center point between the two fingers, we're going to stretch all of the vertices based off of how far the finger moves. That stretch is actually done in this call to the teapot. We're not going to walk through it, but like I mentioned, it just walks through the vertices and moves them by that delta. And finally, again, we're going to push the pointer events to the teapot recognizer to look for those gestures. Now let's take a look at pointer up. All right, and so pointer up now, we're doing a similar thing as we just need to keep our state about those contacts up to date. And so we'll check to make sure that we're actually working with the teapot, not the view again. Then we're going to figure out which contact it is. And then since we're really using pointer left or left position as the first position, we're going to copy all the data from the right one into the left one in the case where the left finger actually came up before the right. Other than that, we're just going to go ahead and reset all the cumulatives because we're going to treat every time a finger comes down or up as the start of a new gesture. So now let's go look at the gesture handlers themselves. And the first thing we're going to do is we're going to pull the things out that are really on the teapot out of the view handlers. So we're going to remove this material color because that's really changing the teapot. And then we're also going to remove this change material color from the tapped handler. Now, in the view manipulation updated handler, so this is when the customer is pinching or sliding their finger, we were just applying it whenever. But now, since we're running the recognizers in parallel, we need to make sure that we're actually interacting with the view and not with the child element. So we'll go ahead and add that if block. Let me close it off here before I forget. Great. And so that's very simple and straightforward. And now the other thing we need to do is to update the view completed handler. And so that's very simple. All we're going to do is we're going to clear up our state to say, hey, we're no longer manipulating the view. All right, and so finally, we're going to go and implement our teapot gesture handlers. And so what you see here now is, again, it's very similar to that code up above. We're going to wait until the hold actually starts. Now we're going to clear, or we're going to go ahead and set this flag, and then we're going to go ahead and move those handlers or those calls to the teapot over like we talked about. All right, so let's go ahead and run that. And so what you'll see now is that you can actually manipulate the mesh. It still rotates. You can tap on it to change the color. And if you start manipulating and you put a second finger down, it'll actually zoom. The press and hold also still works. So I wanted to talk to you a little bit about some of the new features in XAML that allow you to get more power and control over how input's handled. But first, let me talk a little bit about our app. So far, we've been using the SwapChain background panel to use D3D to render our teapot. In Windows 8.1, we're introducing a new control called the SwapChain panel. This control lets you have more flexibility about how DirectX content is hosted within your app. If you want to learn more about that, listen to B. Jordan's talk on unleashing the power of DirectX in your XAML app. Now, the feature I want to talk to you about is Core Independent Input Source. This is a feature we're introducing in 8.1, and it allows you to get input off of the UI thread. So when you use this in conjunction with DirectX, you can actually create a pipeline from the input stack to the output stack. Now, this is similar to what several of our system components do. So for example, take direct manipulation. It's the component that drives panning and zooming. It creates a similar pipeline from the input stack to the output stack in order to provide a smooth panning and zooming experience regardless of what's going on in the app. So if you want to build a pipeline like that and you want to have more control over how you handle input, use the SwapChain panel, Core Independent Input Source, and DirectX to build your experience. So now let's jump back into Visual Studio and I'll show you how to use one of these guys. All right. So let's jump back up to our header here. And the first thing we're going to do is we're going to add another namespace that we're working in so that we can actually get access to the Core Independent Input Source. And now there's going to be a little bit difference in our event handlers here. And so rather than being pointer routed event args, they're actually going to be pointer event args. And that's just the difference between going from the XAML input to the WinRT input, or the runtime input. So now let's go ahead and jump over to our implementation here. And so now we're going to have to make a few surgical changes here. And so the first thing, you get the nice highlighting that shows you that we're no longer correct. So we'll go ahead and update that. We'll just change the archetype. And then the other thing we're going to need to do is we're going to need to change how this point is got. And it's a slight difference, so it's pretty straightforward. And so we'll go ahead and we'll do this for the other ones. So we'll go ahead and get this guy. We'll get the pointer moved. We'll get this guy. Again, we're just, basically the big difference here is based off of how you want that input delivered. So the input is currently being delivered based on an element, which we're passing a null so we get it in screen our client, but we're actually going to use this other way, and that way you're getting it in the window. So let's get this last guy. Pointer is retrieved. Great. So now that we've done that, we've updated it so that it's going to be using the correct pointer event args. Now let's jump over and actually switch it over to use this in the panel itself. So again, we're going to go ahead and add that namespace. And then we're going to jump over to our implementation. And so where we added our controller before, we're going to go ahead and pull this out because we actually want to create this on another thread. And so we're going to jump over to what our render thread is. And we're going to add the controller back again. So now we've created, and now you'll see that we're creating the Core Independent Input Source. And the thing that we're registering for is just touch. We go ahead and wire up our input handlers. And then the last thing that we need to do is inside our render loop, we actually have to call the dispatcher so that we actually get those events. Great. So now let's take a look at how that works. And so we're compiling away. Excellent. And so what you're seeing now is input is actually off of the UI thread. So even if your app was doing complex logic or layout or anything else, this will still stay buttery smooth. So if there's one point and only one point alone that you take away from this talk, it's use the gesture recognizer as the basis for building your custom scenarios. Let it do the heavy lifting, and you can focus your energy on building a great experience for your customers. So what did we talk about today? We talked about the gesture recognizer and how you can use them in your app and kind of the programming model around it. We talked through the zoom bounce effect as a way to demonstrate overriding parts of a manipulation so you can build those nice custom effects. We spoke a little bit about how you go beyond a single recognizer and how you can think about a couple of different models for doing so. And then finally, we talked about using the swap chain panel in order to get more power and more control over how input is handled in your app. There's a few resources here if you want to learn more. I encourage you to go and check them out. Beyond that, thanks for listening, and I look forward to seeing your apps.